5 at the palace. Secant. What are we going to graph to do secant? Cosine. We're going to graph cosine. So even though this graph doesn't have an amplitude because we know the hats go up forever and the hats go down forever, there is still, it's still going to be necessary for us to use the amplitude of 2 to be able to figure out where those hats go, right? Even though there's not an amplitude. Now here's the interesting part. I said I thought only one person would get it right. Let's see if you prove me wrong. The period is 6. Raise your hand if you got a period of 6. Did you really get a period of 6?
No.
So did anybody get it right?
Yeah, phase shift is 6.
Sorry, the period is 4.
Yes.
Yes.
Okay. The phase shift is 6. All right? So that's why nobody got it right. All right. Period is 2 pi divided by b. Raise your hand if you seriously got it right, because I want to be proved wrong. Yep, that's better than I thought. That's like 5, 6 of you. That's 4 of you, because it's a period of 4. All right. 1/2, it's 2 pi divided by 1/2 pi. Guys, always in front of x, whatever is in front of x, including if there's a pi, you got to divide by that to figure out your correct period. Does that make sense? So when I divide 2 by 1/2, I got to make 2 times the reciprocal of 1/2, which is what? And the pi's just cancel. So that's why the period is 4. Phase shift, you're going to have to factor out that dumb 1/2 pi. So when you do that, it's going to be -2. I'll show it this time. 1/2 pi factored out, and it'll be x minus 3 pi divided by 1/2. When you divide by 1/2, you're really multiplying by what? So that's where the 6 comes from. But what happens to the pi? It just cancels. So that's why it is what it is. Vertical shift is what? Then you'll want to make sure you go back and watch this because the asymptote equations don't even have a pi in them. So, and I'll videotape the other one for you. All right, so let's jack this graph. Here we go. What is the period we get to lay down? This blows me away, how some of you right now are like, do I put 4? And do I actually just count 1, 2, 3, 4? I mean, last hour, they looked at me like that was the craziest thing on earth because there was no pi's in it. Okay, yeah, seriously, we get to do this. Watch, watch. We get to go, period of 4, 1/2 of 4 is what? 2. 1/2 of 2 is what?
1.
We get to count by ones. It's back to 7th grade. Okay, but everybody gets so foreign because it's like, well, where's the pi's? I don't know what to do without the pi's. 1, 2, 3. And since we know we're going to phase shift it right, what? We might as well go up to 6. 5. What would be the next one? 6. This is calculus. Okay? And then if you want to go -1, -2, -3, -4, and if you struggle with the left side, you could just negate the right side. All right? Now, what do we graph when we graph cosine? And what do we graph when we graph secant? Okay, we graph cosine. So we're going to graph cosine. But I've got the period done, and I always go in this order. Period, then vertical shift and amplitude, and I do need to use the amplitude here to graph cosine. So we're going to shift it what? Up 1, so I'm going to draw my new middle. I need the new middle, because the middle is where I'm going to find the asymptotes. And I'm going to spot check and show you how to spot check now. Because you can spot check to make sure you have this right. You can know for sure on the test you got your graph right. And I'll show you how to spot check 2 things. An asymptote and a point. Okay? We go up 1. And then the amplitude would be 2 if we were graphing cosine. So we're going to go up 2 from the middle. 1, 2. There's going to be my top of the cosine graph. Down 2. There will be my bottom, which that's -1. You really should label that 2 so I can see your labels on the y-axis. The y-axis will always be by 1s. I might throw a 1.5 amplitude in there just to be a jerk. Okay? I'm probably going to. All right? So cosine doesn't start in the middle. Where does cosine start? At the top. So now I can deal with my phase shift. Now, it usually starts, you go to the middle, and then you would go up 2, 1, 2, but here's the dealio. It's a negative 2, so instead of going up 2, we're going to go down 2. So there's where cosine starts. But I got to do one more thing. Right 6. There it is. You want me to do that one more time? You go to the middle, and you say the amplitude is up 2, down 2. Since it's cosine, it's usually up 2, but since it's a negative 2, we'll go down 2. And then I just got to make it right 6. Okay? And then it just goes like this. Down 2, middle, up 2, middle, down 2, middle, up 2, middle, down 2, middle, up 2. I don't know if I need all this in there, but I'm going to get at least 2 periods. I want 2 periods for sure. You can give me more than 2 periods if you want. All right, where do the asymptotes go? Where you cross the what? The middle. And I'll tell you why it's still there, and I'm going to tell you more importantly why the points are where they are. So go to wherever it crosses the middle. It has to be where it crosses the middle. Okay? And some people get bothered by that. They say, well, I don't understand, because in the parentheses, let me finish this real quick and I'll explain. See, some people get bothered by the fact that it goes where it crosses the middle. Listen, guys, does shifting up or down change? Let me say this. Does shifting up or down really change where the asymptotes are going? Okay, the only reason I'm saying it crosses the middle is because we use the middle to graph cosine. Okay, it's not the y value here. This 1 value here, let's go over here actually. This value of 1 for the y value is not what's making this equal 0 on the inside. Because secant is 0. Or it's making this undefined, this secant value undefined. It's this x value that's making secant undefined. Let me prove it to you. If I plug a 3 in, watch this. Let's see if you can keep up with some really intense mental math here. You ready? I'm actually being very serious, okay? So plug in a 3, and let's see what happens when I plug in a 3 here, and let's see if this ends up being an asymptote. This is how you spot check, know if you got it right. Plug in a 3. What's 3 times 1/2 pi? Well, let's call it 3 pi over 2. 3/2 pi. 3 pi over 2. You with me? Now, what's 3 pi over 2 minus 3 pi? I know, it's a little bit intense, actually. Well, if you got to write it down, 3 pi over 2. First of all, does everybody see how I got the 3 pi over 2? Plug 3 in. Minus 3 pi. What would the common denominator be? 2, so it'd be 3 pi over 2 minus what? 6 pi over 2, which would give me what? Negative 3 pi over 2. So now you take negative 3 pi over 2 and you find the secant of that. Well, let's do this. Unit circle. Negative pi over 2 would be there. Negative 3 pi over 2 would be here. Secant's 1 over cosine. What's the cosine value here? 1 over 0 is what? You get your asymptote. This plus 1 didn't even matter. The plus 1's only going to matter when you go to the point. So do you see how you get the asymptote there now? Now does it make sense why the asymptote goes there? Now let's check a point. Check out 4. 4 should be 3. Let's see if it is. Plug in 4. Plug in 4 for x. What's 4 times 1/2? So you're going to have 2 pi. What's 2 pi minus 3 pi? Now let's do secant of negative pi. Negative pi is over here. Secant's 1 over cosine. So what's the cosine value here? So what's secant? Reciprocate, negative 1. It's still negative 1, right? The reciprocal of negative 1 is still negative 1, right? So now, this is negative 1 then. What's negative 2 times negative 1? 2. What's 2 plus 1?
3.
There it is. It's at 4, 3. Okay? So then you can sit there and you can say on my test, when you go back and check, you say, you know what, I'm just going to go back on my sine and cosine graphs, you only need to check 1 point. But on my secant and cosecants, and my tangents and cotangents, you could check 1 asymptote and you could check 1 point, just to make sure you got it right. Because what you might find is, ooh, my hat was supposed to be down here and I have it up here. I forgot to flip it. Or my asymptote's over 1. Oh, I forgot to phase shift it. Okay? So you might be able to figure out what you did wrong. All right, keep going with this one. Hats would go, I'm going to put my hats in color. All right, hat there, hat here, hat here, hat here, and then hat here, and then hat here. And I've got 3 hats, actually. 3 hats up, 3 hats down. So I actually got 3 periods here. Now, let's see if you remember. Here we go. Here's the big thing you got to remember for tomorrow. Asymptotes for secant and cosecant. Yes?
Do you flip them because of the negative?
I already did that when I took care of my cosine graph.
Oh.
Because we started in the middle. We said it usually goes up 2, but we went down 2. So we already took care of the flip. Okay, so very good question. You don't got to flip again because then you'd be doing a double flip. Okay? Which might be something in gymnastics, like a giant or something, but I don't know the gymnastics league. What would be a double flip called? If you say double flip, I'm going to be mad. Dang it. I thought it was going to be something cool like the Pamchenko. All right, asymptotes. So it'd be x equals start. You still, secant, cosecant, tangent, cotangent. You're always going to have a start asymptote. So what do you want your start asymptote to be here? It's going to be weird this time. It's 1. It could be 3, 1, 5, -1, or -3. I'm going to choose 1. There's no pi in it. I know that bothers us now because we're like, oh, it's trig. There should be a pi in it. Okay, plus, this is going to be weird. It's 2k. Why is it 2k? Half multiples of the period. Cotangent, tangent, it's just multiples of the period. Now remember, this is half the period because it takes 2 sets of asymptotes to go through the whole period. So it's half multiples of the period. So what's the domain then? Yeah, so like Y2K. No power. I remember Y2K. You guys were just born like 99, 98, I imagine, right?
96.
Okay, 96. Well, I was like freshman in college. And Y2K, literally my wife went to the grocery store. We were married at that time. She like ransacked the grocery store. We had like flashlights going out, the gazoo, and candles, and I was like, what do you think's going to happen? Oh, the computers are going to die, and the electricity's going to turn off. I was like, nothing ain't going to. So we waited around till midnight, and sure enough, midnight comes, and I went and I turned the power off. I went to the electrical box and I hit the power. She's like, Jeff, I told you. I was like, flicked it back on. All right, range. All right, y what? Less than or equal to -1, or y is greater than or equal to 3. Okay? Isn't that fantastic? All right, for fun, like this is how much fun I get out of doing these problems. I'm going to prove something. I'm going to do one more problem with you. Okay, one more problem, and then I'm going to be done and I'm going to let you do your problem real quick here. So I need about 10 more minutes of your time. But for fun, before I go to the next video, this is cool. I'm going to prove that 1 plus tangent squared theta is equal to secant squared theta. This was your Pythagorean identity, wasn't it? I'm going to prove it by picture now. Now that you know all the graphs, watch this. This is so cool. You ready? You don't have to draw this, just watch. 1 plus tangent squared equals secant squared. Now that you understand the graphs, let me tell you why tangent and secant are together on the Pythagorean identity. Sine and cosine makes sense to me. It's kind of like, those should go together, right? Sine and cosine, sine squared plus cosine squared equals 1. But why was it 1 plus tangent squared equals secant squared? Why wasn't it 1 plus tangent squared equals cotangent squared? That seems like it makes more sense. The reason why is because tangent is really what? Sine over what? What's secant? It's because their asymptotes are the same. Whole reason they're glued together, these two will be married for life. Okay? They are hooked up. They're married. They'll be married the rest of calculus. Tangent and secant will always go together. Say it with me. Because I'm going to teach you derivative rules in about 5-6 weeks here, and tangent and secant are going to be together. They're going to be joined together at the hip. Okay? So, watch me do this. Tangent. What's the period for tangent? Regular period for just plain tangent. Pi. So pi, we only need to do half marks, so pi over 2. Now I'm just going to go out to 2 pi just for kicks, because I'm going to graph secant in a second. So if I'm doing tangent, okay, here's the full period for tangent, pi. Did tangent start with a point or asymptote? Point. Then it went to what? Asymptote, then what? Point, and then what? And then what? Point. I'm just going to go one past it to go ahead and get this full effect. And then I'm going to graph tangent. You got more than you need, but there you go. Now I'm going to graph secant in red. Red wrong. Okay? Up 1, down 1. Secant, you graph what to do it? Cosine, so it starts in the top, right? So it goes top, what? Middle, ooh, that middle right there is where it crosses the middle, and that's where the asymptote's at. Middle, bottom, middle, top. Draw your hats. The asymptotes are the same, aren't they? I know where they're connected. All right, now here's the cool part. I'm going to prove 1 plus tangent squared equals secant squared with those two graphs. Are you ready? What happens if I square the black one? The black one is tangent. Let's see what tangent squared would be. What would happen if I square the black one?
Everything's positive.
Everything negative would become positive. So now I'll put it in blue. So now you have parabolas.
Steep parabolas.
And then if I add 1 to it, where would those blue parabolas be? Overlaps that one. At Christmas. Now, 1 plus tangent squared is the green ones. Now let's take secant, which is the red ones, and let's square it. What would happen if I square the red ones? Instead of hat up, hat down, hat up, it'd be what? All hats up, and now all the hats would overlap, and we have now proved that 1 plus tangent squared equals secant squared, proof by picture. That was pretty good, wasn't it? Okay? You can do that with sine squared plus cosine squared. This one's even easier. I won't do the 1 plus cotangent squared equals cosecant squared because it's the same thing. And somebody said, well, why isn't it the same as this one? Don't forget, those asymptotes are different. It didn't start with point. It started with asymptote point. So if you actually took 1 plus cotangent squared equals cosecant squared and shifted it over 90 degrees, they would match up. But the 1 plus cotangent squared equals cosecant squared is 90 degrees different. It's shifted 90. So sine squared plus cosine squared is kind of cool. I'll do this one fast, and then we'll do one last example. I'll just do up to 2 pi. 1, 2, 3, 4. There's 2 pi. There's pi. There's pi over 2. There's 3 pi over 2. There's 1. There's negative 1. Sine looks like this. Boom, 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 boom. Cosine looks like this. Okay, you ready? If I take, let's just go to each point. Sine squared. What's 0 squared?
0.
Plus 1 squared?
1.
1 squared plus 0 squared? 0 squared plus negative 1 squared? 0 squared plus negative 1 squared? 1 squared plus 0 squared?
1.
What do you think you're going to get? Now let me prove it. Let's do this one. Let's say we're right here at a half. Okay? Or right here would probably be the same, like root 2 over 2's. Like you would agree that's like root 2 over 2, where those two are equal. Root 2 over 2 squared plus root 2 over 2 squared. What's root 2 over 2 squared? It's math.
Half.
2/4, which is a half. 2/4 plus 2/4. What's 2/4 plus 2/4? So that one goes to 1 as well. Let's do this one. The sine one would be 1/2. The cosine one would be root 3 over 2, right? Do one more. 1/2 squared plus root 3 over 2 squared. What's 1/2 squared? 1/4. What's root 3 over 2 squared? 3/4. What's 1/4 plus 3/4? You get a horizontal line at 1. Sine squared plus cosine squared is 1. There's your proof by picture for that one. So now we've proved both of them by picture. All right, last example I do with you today. And just the last one. We might not go all the way through it. I'll just make sure you guys are okay with the calibrating of the x and y axis, and then I'll let you start. Give you 10 minutes to work on your graph before you leave. Y equals, yeah, there's the one I wanted to do. -3 secant 2x minus pi over 3 plus 2. I'm not even going to let you do it on your own. Let's just talk about it together. Period. Give me the period. How about pi? Why is it pi? It's 2 pi. Remember, sine, cosine, secant, cosecant is 2 pi divided by b. The only one that's pi divided by b is what? Cotangent, tangent. All right, phase shift. Let's get it right. Right, pi over 6. Vertical shift. Up 2. Do we have an amplitude? You should say no. There is no amplitude. Are we going to need to use the amplitude to graph what? You're going to need the amplitude to graph cosine, but are we graphing cosine? No, we're graphing secant. Why are we graphing cosine? So I can locate secant. The only reason we're graphing cosine is to locate secant. All right, let's jack the graph. What's period? Pi. I'm going to leave a lot of room. What's half of that? Pi over 2. Half of that? Pi over 4. Then 3 pi over 4. We're going to shift this right pi over 6 again. That'll be 5 pi over 4. That'll be 6 pi over 4. It's just 3 pi over 2. There's some marks, but they're going to get... I just wanted to do one more where we have to mess around with the marks because I want everybody to feel comfortable with it. I don't think everybody would feel 100% comfortable yet. All right, got the period down? What's the next thing? Not yet. That's the last thing. Always do phase shift last. New vertical shift up 2. There's my new middle. And then what else should I do with it? Amplitude of what? So up 3 from that middle. There's the top. Down 3 from that middle. There's the bottom. So I know my graph's going to be between that for cosine, but then my secant graph will be at the tops and bottoms, your hats. All right, cosine is in the, it's not in the middle. Sine's the only one that starts in the middle. Cosine starts at top or bottom this time. Be down 3. So right here, I'm just going to put a little dot there just to know that's where it starts. But I got to shift it what? Right pi over 6. Where's pi over 6 again? Right before pi over 4. What's the count? Pi over 4. So we're going to have that pi over 6 plus pi over 4 again. Oh, it's kind of the same thing, I guess. So this would be 2 pi over 6 plus what? Be adding 3 pi over 12 again, won't it? We already did one kind of like this one, I guess. But we'll get a lot of marks. So this is pi over 6, which is 2 pi over 12. Sorry, that's 12 there. So what's the next? You got to calibrate all these marks. What you're going to do is all your old marks, just whatever you estimated this, use that same distance and just go a little bit to the left, the same distance as you did on this first one. Make it look like the first one that you did. So just be like, okay, a little bit to the left, a little bit to the left, a little bit to the left, a little bit to the left. Don't forget the y-axis. A little bit to the left, a little bit to the left, a little bit to the left, a little bit to the left. Now let's see if we can label all these, and I'm just going to graph it and call it good, because this is what I want you to make sure you got. So, pi over 6, the next one is 2 pi over 12 plus 3 pi over 12 will be what? I want you to see a pattern here. All right? Add 3 pi over 12. What's the next one going to be? 8 pi over 12, which reduces to 2 pi over 3. This was 8 pi over 12. Add another 3. 11. It gets weird. 11 pi over 12. Add another 3. 14 pi over 12. What does 14 pi over 12 reduce to? 7 pi over 6. Like, have you picked up on a pattern yet? Usually it's too late. You're like, oh, I see it now. Let's do it one more time. This was 14. 14 plus 3 again. 17 pi over 12. You can probably see it. It goes pi over 6, pi over 12, pi over 3. Back to what? Pi over 12, pi over 6. Pi over 12. Anybody want to get a guess on the next one? It'd be a pi over 3. Okay, if you go to the next one, it'd be 20 pi over 12, wouldn't it? What would 20 pi over 12 reduce to? 5 pi over 3. Then you can kind of pick up on a pattern. Now the other side's a little weird because it's not going to be the same thing because it actually goes to, if you 2 pi over 12 was pi over 6. If you subtract 3 pi over 12, it'll be at negative pi over 12. And then back to what? You can't just negate it. I wish you could, but you can't. Negative 4 pi over 12, which is negative pi over 3. And then you have negative 7 pi over 12. And then you'd have negative 10, which would be what? Negative 5 pi over 6. So it's not exact on the other side. It doesn't look the exact same. That's what I want to make sure you understand, is it doesn't necessarily, can't just negate it like you usually could, because it's not symmetric anymore because you pushed it off kilter a little. Okay, you kind of knocked the house off the the base, the foundation, and now it's pushed over a little bit. Okay? Now, when you do this, like I said, it starts here at the bottom. Remember? So we were back down, the cosine starts at the bottom, and it went right 5 or 6. So there's your first mark. And then it would go middle, top, middle, bottom, middle, middle, top, middle, bottom, and then you could go in and put your asymptotes where it hits the middle, okay? And then put your hats in, and then the rest is history, okay? Asymptote equations would be pi over 6 plus, what would it be? Pi over 6 plus what? Pi over 2k. And then domain would be x cannot equal pi over 6 plus pi over 2k. And then the range would just be y is greater than or equal to, what is that? 1, 2, 3, 4, 5. And then y is less than or equal to -1. Okay? Any questions? All right, what I have you do, you got about 6-7 minutes for lunch. Do your problem right now on a piece of paper. And make sure if you got a question on it, come ask me, because don't make your video unless you're absolutely certain you got it right. Okay, so do your problem. I will come in early tomorrow. I'll be here at 7:30 tomorrow. Okay, actually, I might get here at 7. If you're not confident, send it to me and I'll say yes or no. I'll sign off on it.
We'll say no.
Don't make a bad problem. If you watch a video and you find somebody made a mistake, you let me know, because I'll take points off their video and I'll give you extra credit.
Can I take? I'm gonna be gone tomorrow, so